Hi, I'm Stephanie McClellan, the Director of the Special Initiative on Offshore Wind in the College of Earth, Ocean, and Environment at the University of Delaware. As a part of the module on low emissions electricity and renewables, this session examines wind power, or specifically, the conversion of the movement of air into electrical power. The session will cover wind power as a low-carbon solution for climate change, addressing the state of wind power today and opportunities for expansion to tap more of our wind resources to meet even more of our global electricity needs. The use of wind turbines to generate electricity began just about 35 years ago. The earliest adopters were the United States and Northern Europe, with Denmark and Germany leading the way. And in the early 2000s, India gave wind power a truly global profile, with China quickly following and then surpassing them. At the end of 2016, there were 487 gigawatts of wind power installed on 6 continents. Asia-Pacific, which started at the very end of our wind power history, today has the most wind power capacity, followed by Europe and then North America. Yet, even with the rapid expansion of wind the world over, wind power today represents only 3.7% of global electricity. And while this is a small fraction of the world's electricity, wind installations do represent the majority of new electric generating capacity. In the US in 2015, wind energy installed more electric generating capacity than any other energy source in America. 8.3 gigawatts of wind were installed compared to 7.3 gigawatts of solar or to 6 gigawatts of natural gas. Globally, the numbers are very similar. While the lion's share of wind power has been installed in North America, Asia, and Europe, and while their markets are all expected to continue to grow, Latin America is an important emerging market, with Brazil and Mexico leading the way there. So where does wind fit into a low-carbon future? According to the International Energy Agency, by 2050, 95% of electricity will need to be low-carbon in order to limit the rise in global temperature to 1.5 degrees Celsius, which experts say will be necessary to avoid catastrophic consequences of climate change. And according to the Global Wind Energy Council, to achieve those goals and for wind to do its part, wind power would need to increase to around 20% of global electricity by 2030. And we're going to want wind to do its part because it's an abundant source of low-carbon electricity. Here's how it works. When the wind blows over a wind turbine's blades, it lifts and rotates them, causing the rotor, which is simply the blades and the hub combined, to spin and turn the generator, which is what produces the electricity. The electricity generated in each turbine travels through wires down the turbine and then is collected by a wind farm's cable system. It's then transmitted to the wind farm substation and from there onto the power grid. For wind power to reach its potential as a climate solution, it will need to expand quickly and significantly. Part of doing this is just a matter of making adjustments to today's technology. The earliest wind turbines generated electricity only in the kilowatts. By today's standards, those turbines are very small. But since 2000, turbines have been generating megawatts of power per turbine, growing from 1 megawatt to 2 megawatts to 4 megawatts to now 8 megawatts in size, which is the largest installed turbine in the world. It is important that turbines increase in size because it's the size of the rotor in the generator that determines how much energy a turbine can produce. Simply put, the bigger the turbine, the more energy it gets from the same wind speed. And the wind industry is hard at work developing bigger turbines with 10 megawatt and even 20 megawatt turbines on the drawing board for the not-too-distant future. In addition to developing technology to get more energy from the same wind speed, there are other significant opportunities to increase how much wind power we can harness. First, consider this. Wind power capacity today exclusively harnesses winds near the Earth's surface, and nearly all of the wind power capacity in the world is installed on land. By tapping winds over the ocean and those at higher altitudes, there are opportunities to significantly expand where we can harness wind. Arguably, the greatest opportunity for tapping a robust resource of high wind speeds in the near term is offshore wind power. When you look at the wind speeds across the globe, it is clear to see the largest wind resources are above the oceans and the mid-continental plains of major continents. And as you can see on this map, the coastal oceans have the most wind of all. And that's important because not only do they have the strong wind, but they're also closest to most of the world's population, and then, of course, their electric use. The winds that blow over the ocean are not only stronger, but in general, they blow more consistently than the wind over the land. And in many places in the world, offshore wind blows during the day when the demand for power is at its highest. To date, 14 gigawatts of the 487 gigawatts of installed wind power capacity is installed in the ocean. That's about 3% of all the wind power capacity in the world. And nearly 2/3 of that has been installed in just the past 5 years. The UK has been the leader in tapping offshore wind resources, with other northern European countries, as well as China, making headway. An offshore wind farm is very similar to an onshore wind farm. The turbine technology used on land is used, except bigger to handle the higher wind speeds. The turbines are arrayed in the ocean, similar to an onshore wind farm, and it's where the electricity is stepped up in voltage before transmitting it back to shore via buried cables, where it connects to an on-land substation and ultimately to the power grid. Across the globe, there's a very large amount of ocean space where the water is shallow enough to use a fixed bottom platform. That's the type of turbine platforms shown here in this illustration, the 3 most left turbines. The structures are mounted on the ocean floor. And depending on what type of fixed bottom foundation is used, this type of technology can be used in waters up to, roughly speaking, 50 to 80 meters deep. But much of the world's offshore wind resource is above waters that are much deeper. And on this graph, the blue bar represents the amount of offshore wind power potential in deep water compared to the amount of the wind resource in shallower waters. The deep water resource is tremendous. And in order to harness those winds over deep water areas, a different technology is needed. And so again, looking at this illustration, you can see that the turbines are erected on floating foundations, and they can be seen here, the 3 rightmost turbines on the illustration. The wind industry is just now dipping our toes into these deeper waters. Demonstrations of floating wind are in the water in Portugal, our toes into these deeper waters. And today in northern Scotland, the world's first floating offshore wind farm is currently under construction. Thus, the world's offshore industry is not only growing quickly, but is now going into deeper water, opening up more and more of the world's near-surface wind resources to provide carbon-free, renewable electricity. But in addition to looking off of our coasts, we can also begin tapping into the winds by looking to high altitude. Consider first that the average wind turbine's hub is located about 100 meters above the Earth's surface. That simply means that the wind that is captured by the average turbine is the air that is moving at about 100 meters above the ground. As these figures show, across the globe, as you move up to 1,000 meters, the wind power increases and it only gets windier the higher you go. The entirety of the world's 487 gigawatts of wind power capacity that's installed today is built at the very lowest levels on these graphs. Again, there's significant opportunity to expand wind power by harnessing the winds high above us. First, we can use the same type of technology as we use today, but we can use taller towers to raise the hub height to where the velocity of the wind is higher. Denmark, for example, is preparing to test turbines up to 300 meters high, which for comparison's sake is as high as the Eiffel Tower in Paris. The U.S. Department of Energy is conducting research and development also on how to bring these to market. But at the other end of the spectrum, we can begin to tap the Earth's full wind resource by using innovative technologies to capture high-altitude wind. This type of wind power is called airborne wind energy. It uses kites, drones, and turbines and balloons to make electricity from winds in the 600-meter to 1,000-meter range. And what was once an interest by hobbyists is now attracting major energy companies and investors because they see that this could be a low-cost, non-intrusive source of large amounts of renewable energy. So there's quite a lot of opportunity to expand our use of wind power by literally aiming our sights higher. In summary, we can work to capture more energy from the same wind speeds on land near the Earth's surface by making bigger and more efficient turbines. We can aggressively pursue offshore wind and truly open up a whole new wind resource. And we can access higher wind velocity by building taller turbines and tapping into higher altitude winds with airborne wind energy devices. Taken together, the near-surface winds on land and over the ocean, coupled with the wind resource at high altitude, is abundant enough to meet several times more than all of humanity's energy needs. We have the technical ability to harness all of these aspects, making wind energy a very promising part of the solution to global climate change.